The next one is acceleration. What is acceleration? So the acceleration can be defined as the change in what? Velocity of a body per unit time, or the rate of what? Of change in velocity is what? Is as a what? Acceleration. I say what? Acceleration is the what? Acceleration is the rate of change in velocity. Or we can also call it what? Acceleration is what? Is the velocity per unit what? Is the change in velocity per what? Per unit time is acceleration. So mathematical acceleration is it is measured in meter per second square. And it's also a what? It's also a vector quantity. It is a vector what? Quantity. So mathematically, acceleration can be expressed in form of this. Relation A is what? Change in velocity over what? Over time. That's the acceleration formula. This change of velocity can be in this form. You can have what? Acceleration. We use A to write it. A because of the what? Change in what? No. Once I use A, change in velocity over what? Over T. So you can now say what? Where this change represents final velocity minus initial what? Velocity. You can put it there. You can have A should be what? V minus what? U over what? Over T. This is also what? Another acceleration what? Formula. And the acceleration also divided into what? Into 4 parts, like speed and velocity and what? Speed and velocity. So we have types of what? Acceleration. So other types of acceleration, we have uniform acceleration, we have non-uniform acceleration, we have average as a what? Acceleration. The third one we have instantaneous acceleration. So let's take it one after the what? The other. So as we all know, for the uniform acceleration, for this uniform acceleration, when the what? The rate of change in velocity time is what? Is constant. When the what? The change in velocity per unit time is constant, what do we have? We have uniform what? Acceleration. But if the what? The rate of change in velocity with time, t, is not what? Cause what? Constant, is called non-uniform what? Acceleration. When the change of velocity with time is constant, uniform acceleration. When it's not constant, non-uniform what? Acceleration. So the average acceleration is the ratio. The average acceleration is the ratio of what? Of change in velocity traveled with what? With time. That's what we call what? Average what? Acceleration. And the average acceleration can be right in this form. So what? Average as a what? Acceleration is the what? Change. Ratio of what? Change in velocity traveled over what? Over time. And it's also measured in what? In meter per what? Per seconds. The last aspect under acceleration is instantaneous acceleration. So the instantaneous acceleration is the acceleration of the what? Of a body at a particular point in time. So the acceleration of a body at a particular point in time, we call it what? Instantaneous acceleration. This is the what? The acceleration of a body or particle at a particular point in what? In time. And the instantaneous acceleration can be expressed mathematically as acceleration A, so it was the V, the T, or the L square X, the what? The T square. So this is the formula for acceleration of a body at a particular point to what? In time. Like I said earlier, in that time, if you are given what? If we are given that V is equal to xi plus yj plus zk. We are now asked to what? To find the acceleration of this body, which is moving what? In meter per seconds. That's what? The acceleration will be what? A equal to what? The V, the T. We are given this as what? Our velocity. So you will now apply the what we call what? Differential calculus, which I said what? We have the what? The x over the t I plus what? The y, the t. So we have the what? The y, the t, j plus the z, the t, k. That's how it works. So we use it. But and let us solve questions on how we use what? The how we can apply the instantaneous acceleration in calculation. Now, example 1. Let us solve this question. We are given that the position of a particle moving along x-axis is given by this. We are given that what? Solu. X in function of t as 2x raised to power 3 minus 6t plus 5, everything in what? In meter. Where x is the meter and time t in seconds, find the velocity of the particle. So we are asked to find the what? Velocity first of the particle. So to know the velocity of the particle now, what we do? Look at what our velocity is what? The what? The x, the what? The t. So let us differentiate this s given. By derivation, 3 times 2 give us what? 6 t. This t, the power of t is 3 minus 1. It remain what? 2. Then minus 60. Derivative of the power of t here is what? Is 1. 1 times 6 will give us what? 6. 60. It will be what? 1 power of this minus 1. Subtract it. 1 minus 1 will give us what? 0. 3 to the power 0 is what? Is 1. So we still have, we have what? 6 here. For this plus what? 5. It will give us what? 0. Derivative of what? Of constant is 0. So you now have what? This plus this meter per what? Per seconds. That is what? The velocity. So the second one, we are asked to find the what? The acceleration. The acceleration of the body was acceleration of what? Of the particle at constant d. So we know that acceleration A is what? The V, the what? The T. So what is the V given? V, our V now is what? 6t squared minus t. You will not differentiate the what? The t back. With value to what? Differentiate to what? This value given. Whereas 2 times 6. You know, as is this, the V, the T, abi? I say what? Given that, or where we get it, they are not giving us. Where what? Velocity V is what? 6t squared minus 6. What we get A. What we now do next is what? It will be acceleration A is what? dv dt. 2 times this, we have 12t minus 6. Sorry. Of this 6 is what? 0. Acceleration is what? 12t 12t meter per second square. But we are given that what? At particular instance, which is what? T at t equal to what? 2 seconds. So what are you going to have? We will have what? Our acceleration A should be now equal to what? 12t times 2, which is equal to the what? 24 meter per second square. That is what? As a what? Acceleration. So before we move forward, permit me to solve more questions on this. Solution. Let's look at the solution to example 2. We are given that what? The relation 3t equal to the square root of x plus 6. Describe the displacement of the particle in one direction, where s is in meter and the t in seconds. Find the displacement when velocity is what? Is 0. This question is not straightforward, but let us look at it. We are given that what? The relation is what? Let me say, given that three what? 3t is equal to the square root of 3x plus 6. Describe the displacement of the particle in one direction where s is in meter. Let us make this x as well as the formula. By making s a formula, this will go here. You can have what? 3x root of 3x equal to the what? 3t minus 6. By removing this square root, so what? Let's square both what? Let's square both sides. By squaring the both sides, this will give us what? 3x, this which we what we remove. We have 3t minus 6 everything what? Square. So this is the same thing as what? 3x. 3t minus 6 square is the same thing as 3t minus 6 into what? We write it twice. 3t minus what? 6. So you now need to what? To expand. By expand the expression, we have 3x to be, you multiply, or let me solve it as layman. T minus 6, then minus 6, 3t minus 6. So you now have 3x, 3 multiplied by 3 to give us what? 9t square. 3 times this is minus 18t. 3 times this is minus 18t. Here we have 6 times 6 plus 36. By expand this, we have 4. Now have what? We have 3 here all under now. We have 3x is what? 9t square. Add this together. 18. If I'm not mistaken here, 3 times this 18. This 18 t. So 18 plus what? Plus 18, 40, 36 is minus what? 36t plus 30 what? 6t. So if you divide what? That's, we have 3 here, we have 3 here. 3, 3 here, we can have what? 3x, 3 in 9 is 3. 3 as common factor. We have what? 3t square. 3 here, we have 12. See, 3 here, we have what? 12. So this 3 cancel this 3. We are now left with what? Our x will be what? 3t square minus 12t plus 12. Everything in what? In meter. You can see that I said the question is not straightforward. So from this relation given here, we extract our what? Displacement x. And this displacement x. So when you are done with what? With displacement x, the next thing that we do now is what? You will now find what? Velocity. You have to find the displacement when velocity is equal to 0. But our velocity is what is unknown. Yeah, we must use this displacement to determine the velocity. So the final answer will now get the velocity. We will now use to what? To find our what? Displacement. So let me divide the board. Yeah. So we have displacement as this now. So to know the velocity is what? This what? Displacement over what? Over time. Well, what is our displacement here? 2 times 3. It will give us what? 6t. Remove 1 from the power of 12 is minus 12. This will be 0. So this is my velocity in meter per what? Per seconds. But you are now asked that what? Find the displacement. Oh, this is what? Velocity is 0. That's what? When velocity is equal to the what? 0. The final average thing you get here. That's what? V is equal to what? 60 minus 12 equal to the what? 0. So from this expression now, we can have 60 equal to the what? Plus what? 12. Here, t equal to the what? 2 seconds. So when this is our velocity that we get, but they said when velocity is equal to 0, equate it to the 0 to get your what? To get your t. The final answer you get for t here is what we use to what? To determine our what? Our displacement. So what is displacement now? So this will be displacement. Now what? Displacement x is what? 3x squared minus 12t plus 12. So t equal to the 0, x equal to the what? T equal to 2. 3 into what? 2 square minus 12 into what? Into 2 plus what? Plus 12. 2 square is what? Is 4. 4 multiplied by 3 to give us what? 12. So the x here equal to the what? 12. 2 times this minus 24 plus what? Plus 12. Add it together to equal to the 0. So displacement is will be equal to the what? 0. So what is the final answer here? Answer is what? It's A. So let us solve more questions on this. So what? Solution for the third example. Then an elementary particle is projected into space and travel as we are given that what our R is t cube plus 2t I minus 3e exponential 2 minus plus 2 sine 5 tk. So we are now asked to what? To find its acceleration and its magnitude at t equal to the what? Equal to the 0. But don't forget that what we are given what? We are given the what? The displacement. We are given what? Displacement R. And we all know that what? Before we can get the acceleration, we must know what? What? Velocity. So if we differentiate this displacement, it will give us what? Velocity. When we now differentiate velocity further, it will give us what? As a what? Acceleration. So here now, let us differentiate the velocity, the displacement to know the velocity. Velocity is what? The what? The R over what? The T. So let us derive the what? R. Here, the thing will come to the front. We have 3t, subtract 1a square. The derivative of 2t will give us 2. So we are I, done with that one. But here we have what? Exponential function. If you have a y equal to the what? E exponential 3x. The derivative, the y, the x for this function, 3 will come to the front. The 3e exponential this. If we are given what? We have what? Y should be e exponential what? 10x. dy dx will be what? 10e exponential what? 10x. That's how we differentiate what? Exponential function. So here now, with knowledge of this, what do we do now? This power will come to the front. So we have minus here. Minus times minus give us what? Plus 6e minus what? 2t. Hey, I forgot j here. 2t what? J. See, how do I get this one? 2 multiplied by 3, 6. E That's how we denote what? Exponential function in differentiation. And the next one is what? Sine. Whenever we have y equal to the what? Sine theta, derivative of the y ds of sine theta is always cos what? Cos theta. If y is equal to the what? Cos what? Cos theta, the what? The y, the s for cos theta is always what? Minus sine what? Sine theta. If we differentiate sine, it will give us cos. If we differentiate cos, it will give us what? Minus what? Minus sine. And again, assume we have y should be sine 2 theta. Sorry, I put theta here. The theta. The what? The theta. 2 theta. dy, the what? The theta will be what? 2 sine what? Sine 2 theta. So whenever you are differentiating what? Trig function, the value you have here will come to the what? To the front. So let us apply it here to now. To differentiate what? The sine 5tk. The 5 will go to the front to become what? 10 cos 5tk. That is what? The velocity of what? Of the particle. Next one is for what? Acceleration. What? For as a what? Acceleration. This one for what? For velo what? Velocity. So for acceleration now, what can we do? You now said what? You will differentiate everything you have for velocity to get what? As a what? Acceleration. Now let us differentiate. We have acceleration. A is what? The v, the t. Now add this 60. 2 will give us what? 0. We have 60 what? I. Add this again. It will give us what? It will go to the 4. Minus 2. Minus 2 times 6. Minus 12. E exponential minus 2t. Here we have what? J. Here. Here plus. We have this cos this. This will divide cos. I said to give us what? Minus sign. So the minus, we have what? Minus 5 times 10. Give us what? 50 sine 5tk. Derivative of cos is minus sine. Minus you cancel this, is will be have this 5 times 10, 10. Now we have here. The last thing is what? This is our acceleration. But find its acceleration and its magnitude at t equal to the what? So we can now say what? Hence, at t equal to the 0, let us substitute for what? T equal to 0 here in this equation. So we have what? Yeah, t equal to 0. A will be what? 6t equal to the 0 here. I minus 12 e exponential t 0 minus 50 sine 5t k. So 6 times 0 times a equal to 0. And here we have minus 12 e. 2 times this is 0. This power 0. Everything 50 sine 5 0. So I'm going to put 0 here, sorry. So everything here will get to give us what? 0. So the final answer is what? Acceleration is minus 12 e exponential 0. From law of indices, anything to power 0 is what? Is 1. We now have what? Acceleration A. Acceleration A equal to what? Minus 12, 1. We now have A should be what? Minus 12 meter per seconds. I forgot J here. J, J, J. So we have J here. The final answer will be what? 12 minus 12 J meter per seconds. We are now asked to find the what? Magnitude. That's a what? Magnitude of acceleration. A. It will be what? A magnitude will be minus 12 square root. So minus 12 square will be 144. So the final answer at the end of the day we have what? A magnitude is equal to the what? Is 12 meter per second square. That's all about the what? About this what? This question. So the next thing that we are going to treat now is what? Is a graph in a particle kinetics.